Hi guys, so in this video I will continue with the last subtopic of chapter 8, which is the probability, which is the conditional probability. So for conditional probability can be for dependent events and independent events. Okay, before this video starts, so let me do a disclaimer. So for this video, I get this source from a website which is this www of mathsisfun.com. So I will to attach the source of this www of .mathsisfun.com at my description, so to prevent for any other people save me from copy. So I will attach this source under the description. So if you're interested, you can see the this website. Okay, so let me start this video. Okay, for dependent events, the events can be dependent, which means they can be affected by previous events. So, example, marbles in the bag. Two blue and three red marbles are in the bag. So, what are the chances of getting a blue marble? So, the chance is 2 in 5 because of two blue marble in 5 marble, right? But after taking out the chance change, so the next time if you got a red marble before, then the chance of blue marble next is 2 in 4. If you got a blue marble before, the chance of a blue marble next is 1 in 4. This is because we are removing the marbles from the bag. So the 5 in 5 will be in 4. So replacement. If you replace the marbles in the bag each time, then the chances do not change. So the events are independent. So conclusion, with replacement, the events are independent. Without replacement, the events are dependent. A tree diagram is a wonderful way to picture what is going on. So let's build one for our marbles example. Okay, so from the sources of what the maths is fun given, we just use the example from it. So there's the 2 per 5 chance of pulling out the blue marble and a 3 per 5 chance of red. We can go one step further, see what happens. We pick the second marble. 1 per 4, 3 per 4, 2 per 4, 2 per 4. Yeah. If a blue marble was selected first, it's now 1 per 4 chance, getting a blue marble and a 3 per 4 chance of getting a red marble. Conversely, if a red marble is selected first, there are now 2 per 4 chance of getting a blue marble and a 2 per 4 chance of getting a red marble. Okay, now we can answer the question like, what are the chances of drawing 2 blue marbles? So it's a 2 per 5 chance followed by 1 per 4 chance. So the chances of drawing two blue marbles is 2 per 5 times 1 per 4 will be 1 per 10. So in this case, let me introduce the notation of probability. This is PB, right? So this is PB sub B, right? So how about this? How should I write it? In this case, I use this notation. P, sorry, P, B, straight line, B. Okay, let's see how it works. So PA means the probability of event A. So if our marbles example, event A is get a blue marble first, the probability PA equals to 2 per 5, and event B is get a blue marble second, but for that we have two choices. If we get a blue marble first, the chance now is 1 per 4. If we got a red marble first, the chance now is 2 per 4. So we have to say which one we want and use the symbol, this notation, to mean given. So P, B notation A means event B given event A. In other words, event A has already happened, and what is the chance of event B? So PB notation A is also called the condition probability of B given A. So in our case, you can see PB given by A is 1 per 4. So PA, this is the event A, this is the event B, get the 2. The event of B getting the second blue marble, given that the first first marble is blue. So you need to write this notation. And we write it as P A, sorry, this is A sub B equals to PA times PBA. So you can take note. If got this notation come out, so you should, how to know that you need to use this notation? So you can just see the question. If the question got this keyword given, so you know this question asks you to use this notation. So finding the hidden data. So use algebra, we can also change the subject the formula. So just now I write this. So this P B over A, so same as this P A sub B, also same as B sub A. So B sub A P A. As you can see, P A times P B over A, P A over B. So P B over A, so will be P A sub B or B sub A, also which are same also, divide by P A. Another example is ice cream. Like 70% of your friends like chocolate, 35% like chocolate and like strawberry. What percent of those like chocolate also like strawberry? So you need to find the percent, which is 70% like chocolate, right? Is 35% divided by the 70%. Who's like chocolate? Given that the person like chocolate. Also like the strawberry. Yeah, you know that? Can you catch the keyword? Given the friends like chocolate. So what percent of these friends who like chocolate, given that they like chocolate, also like the strawberry? So we need to find the percentage, which is 0.35 divided by 0.70. So we'll get 0.5, which is 50%. So you know that given your friends who like chocolate, so among the friends who like chocolate, 50% of them also like strawberry. Yeah. Can you get it? So you can just write like that. If given B, so you need to divide the probability of B. So the probability of B is larger than 0. If A is given, so you need to divide the probability of A, so PA larger than 0. So PA notation B is the probability of A given B. So the keyword is given. Given is a keyword. Okay. After the dependent events, let us see the independent events. So two events are said to be independent if the occurrence of one event does not affect the probability of another event occurring. Example, tossing a coin. Because each toss of a coin is a perfect isolated thing. What it did if the past will not affect the current toss. The charge is simply 1 in 2 or 50%, just like any toss of the coin. So like this, if I get, yeah, if I get hit, it if I get hit at first, if I throw the next toss, I can also get the hit or the tail. It does not affect the result in the next toss. So this is called the independent events. So if events A and B are independent, then PA given by B is also same as PA. And P, the probability of event B given by event A is also same as the probability of event B. So because the event given are not affected by the probability, so they are the same. So for the conditional event, so you can write as PA sub B equals to PB times PAB. So, so we arrive at the end row of the independent events. So, conclusion, two events A and B are independent if and only if the PA sub B is equal to PB PA times PB. As you can see, right? This this is PB. This A given by P is also same as PA. So it can be write as PB times PA also. So this is the mutually independent. So we see the question. Given A and B are two events where PA equals to 1 over 2, PB prime equals to 1 over 3, and PA union B is 3 over 4. So find these four things. Okay. Let me construct. PA is 1 per 2. So A prime also 1 per 2. PB prime 1 per 3. So PB equals to 2 per 3. A union B is 3 over 4. So A union B, as you know, that A union B is 1 minus PA prime sub B prime. So A prime sub B prime, 1 minus 3 over 4, so I will get 1 over 4. This is what they given. So the letters that's given is this. Let me write it first. After I find the value, I only write it. So first, PA sub B. So I have this PA union B equals to 3 over 4 minus 1 over 2 plus 2 over 3 minus this PA sub B. So PA sub B, I do calculation, I will get 5 per 12. So 5 per 12. This time I can do calculation. So 1 over 2 minus this, so I'll get 1 over 12. This, I will get 1 over 4. Just like this. B, probability of A given B. So by using this formula, A sub B divided by PB, 5 over 12 divided by this probability of B, be aware, 2 over 3 here. So 5 over 12 multiplies 3 power 2, so I'll get 5 per 8. C, probability of B prime given A prime. So B prime sub A prime divided by A prime. So take this A prime and so 1 over 4, 1 over 4 divided by 1 over 2. 1 over 4 at here divided by 1 over 2. A, right here. Oh, 1 over 2 at here because it's A prime. I get wrong. So 1 over 4 times 2, so I will get 1 over 2. And the last, P A prime given B. So P A prime sub B equals to PB. So 1 over 4 divided by 2 over 3, so 1 over 4 times 3 per 2, so I will get 3 per 8. Second question. So for any set R and S, PR equal to PS sub R and PS prime sub R plus PS sub R. Okay. is just like this. So I want R P S prime sub R, which is here. And S sub R is at here. So show that PS given R is 1 minus PS prime given R. C. So we know that by using the formula given, PR equals to PS prime sub R plus PS sub R. So I move the PS sub R at here, PR minus PS prime sub R. So you know that this equation. So PS given R, PS sub R divided by PR. So by subbing this formula inside, P R minus PS prime sub R. So I separate it. PR divided by PR equals to 1. PS prime sub R given by PR, so will be PS prime this given R. So shown. So if PR equals to 0.5, PS prime equals to 0.3, PS prime given by R is 0.4, so elaborate this PR union S. It also can be written as PS union R. So before that, let me find value of PS. So 0.7 PS sub R equals to, use back this formula, 1 minus PS prime sub R. So PS sub R, I know that, I don't know yet. 0.5, this 1 minus S prime sub R, 0.4. 1 minus 0.4, 0.6. So PS sub R, 0.3. PR union S, so I use the additional rule, PR plus PS minus PR sub S or S sub R. Also the same, PS sub R, from here I get 0.3. So 0.5 plus 0.7, 1.2 minus 0.3, 0.9. Here's the answer. I think this is the last question. 500% has male and female were asked if they are in favor or against capital punishment. In favor of or against. Over the 300 males, 125 are in favor, whereas 145 females are against. So in the person are selected at random from this 500%. So find the probability that the person is in favor given female, which is I, F. This is I or F. So the events are independent and mutually exclusive, which is the male and in favor. So give explanation. Okay, so before that, I let F as female, M as male, I is the number of person in favor, A is the number of person against, and I construct the contingency table. It given 500 people and 300 male and 125 of them in favor, and 145 of female are against. So what I get, I can just do calculation at here. The pink color words are the numbers that I calculated later. So I given F, so PI sub F divided by PF. So I sub F is 55 at here, divided by 200. So 55 divided by 200, so I will get 11 per 40. In favor of female, so I use the additional rule. Pi plus Pf minus Pi sub f. 180. Where I get a 180? Ah, Pi. Sorry, I think this I write wrong. 125. 180. Yeah, is correct. 180 plus 200 minus 55, so I'll get 13 per 20. Or you can just 1 minus Pi prime plus F prime, which is Pa sub M. So we'll get 1 per 175, 500. So also same as 13 per 20. Okay, so to find is it mutually independent? So I need to find M sub I equals to M sub I 125 per 500, which is 1 per 4. So PM times PI, 300 times 100, also 27 per 125. So they are not independent. And besides, because PN M sub I, it is 104, it is not equal to 0, so it's not mutually exclusive also. This is how the way you explain it. You explain it like not like the science, like not like science like biology. That's you need to explain it theoretically. In this case, if they ask you explain, so you can explain it mathematically by proving they are not independent and proving they are not mutually exclusive by using mathematical formula. So here is the end of the chapter 8. So thank you for watching and bye.